Hello children, I am Ekta. Imagine you are walking in a park and you notice various shapes all around you. As you observe, you come across different types of four-sided shapes such as a playground slide, a picture frame and a soccer goal net. These shapes are called quadrilaterals and they have unique properties and characteristics. In this lesson, we will explore the world of quadrilaterals, understand their different types and uncover their fascinating properties. Let's dive into the realm of four-sided wonders. In this lesson, we will embark on an exciting journey to explore the world of quadrilaterals. We will discover the different types of quadrilaterals such as squares, rectangles, parallelograms, trapezoids and rhombuses. We will also learn about their unique properties and relationships. By the end of the lesson, you will be able to identify and classify quadrilaterals based on their properties and solve problems involving their attributes. Learning outcomes. At the end of this lesson, you will be able to understand the properties and characteristics of quadrilaterals. Identify and classify different types of quadrilaterals. Apply the angle sum property of quadrilateral to find unknown angles. Apply the midpoint theorem to determine parallelism and equality in triangles. Use the midpoint formula to find the coordinates of the midpoint. Keywords. Keywords from this lesson are quadrilaterals, squares, rectangles, parallelograms, trapezoids, rhombus, attributes, angles, sides, diagonals. Quadrilateral. A plane figure bounded by four sides is called a quadrilateral. In the following figure, four line segments AB, BC, CD and DA bound a quadrilateral ABCD. In the given figure, we have the points A, B, C and D are the vertex of quadrilateral ABCD. The line segments AB, BC, CD and DA are the sides of quadrilateral ABCD. The line segments AC and BD are called the diagonals of quadrilateral ABCD. Types of quadrilaterals. Various types of quadrilaterals are parallelogram. A quadrilateral in which opposite sides are parallel is called a parallelogram. In the figure, ABCD is a parallelogram. Here AB is parallel to CD and AD is parallel to BC. Also, opposite sides of parallelogram are equal. Rectangle. A parallelogram, each of whose angle is 90 degree, is called a rectangle. In the figure, PQRS is a rectangle. We write it as rect PQRS. Square. A rectangle having all sides equal is called a square. In the figure, LMNO is a square. Rhombus. A parallelogram having all sides equal is called a rhombus. In the figure, PQRS is a rhombus. Trapezium. A quadrilateral in which two opposite sides are parallel and two opposite sides are non-parallel is called a trapezium. In the figure, BCDE is a trapezium. Note, if the two non-parallel sides of trapezium are equal, then it is called an isosceles trapezium. Kite. A quadrilateral in which two pairs of adjacent sides are equal is known as a kite. PQRS is a kite such that PQ is equal to QR and PS is equal to RS. Properties of parallelogram. The opposite sides of parallelogram are parallel. A diagonal of parallelogram divides it into two congruent triangles. The opposite sides of parallelogram are equal. The opposite angles of parallelogram are equal. The consecutive angles of a parallelogram are supplementary. The diagonals of parallelogram bisect each other. Now we will see one important theorem. Angle sum property of a quadrilateral. The sum of all the four angles of quadrilateral is 360 degree. Let us prove it. In a quadrilateral, ABCD join BD, since the sum of the angles of a triangle is 180 degree. Therefore, in triangle ABD, we have angle 1 plus angle A plus angle 2 is equal to 180 degree. Equation 1. In triangle BCD, we have angle 3 plus angle C plus angle 4 is equal to 180 degree. Adding 1 and 2, we get angle 1 plus angle A plus angle 2 plus angle 3 plus angle C plus angle 4 is equal to 180 degree plus 180 degree. Angle 1 plus angle 3 plus angle A plus angle C plus angle 2 plus angle 4 is equal to 180 degree plus 180 degree. Angle B plus angle A plus angle C plus angle D is equal to 360 degree. Since angle 1 plus angle 3 is equal to angle B and angle 2 plus angle 4 is equal to angle D. Angle A plus angle B plus angle C plus angle D is equal to 360 degree. Therefore, the sum of the four angles of a quadrilateral is 360 degree. Midpoint theorem definition. The midpoint theorem states that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of the third side. DE parallel to BC and DE is equal to half of BC. Midpoint formula. The midpoint of any line segment is defined as the coordinate point that divides the line segment into two equal parts. Suppose P x1, y1 and Q x2, y2 are the coordinates of endpoints of any line segment, then the midpoint formula is given as midpoint is equal to x1 plus x2 by 2, y1 plus y2 by 2. Example, in triangle ABC, the midpoints of BC, CA and AB are D, E and F are respectively. Find the value of EF if the value of BC is equal to 14 centimeter. Solution. Given BC is equal to 14 centimeter, if F is the midpoint of AB and E is the midpoint of AC, then using the midpoint theorem, EF is equal to half of BC. Substituting the value of BC, EF is equal to half into 14, EF is equal to 7 centimeter. Therefore, the value of EF is equal to 7 centimeter. Let us see another example. In a parallelogram ABCD, the bisector of the consecutive angles, angle A and angle B intersect at P. Show that angle APB is equal to 90 degree. Solution. ABCD is a parallelogram. AP and BP are bisectors of consecutive angles, angle A and angle B. Since the consecutive angles of a parallelogram are supplementary, angle A plus angle B is equal to 180 degree. If the give equation divided by 2, we get half angle A plus half angle B is equal to 180 degree by 2. So, angle PAB plus angle PBA is equal to 90 degree. In triangle APB, angle PAB plus angle APB plus angle PBA is equal to 180 degree. Angle APB is equal to 180 degree minus angle PAB plus angle PBA. Substitute the value of angle PAB plus angle PBA is equal to 90 degree. We get 180 degree minus 90 degree is equal to 90 degree. Hence proved. Example, in a parallelogram ABCD, P and Q are the points on line DB such that PD is equal to BQ. Show that APCQ is a parallelogram. Solution. ABCD is a parallelogram. OA is equal to OC and OB is equal to OD. Diagonals bisect each other. Now, OB plus BQ is equal to OD plus DP. OQ is equal to OP and OA is equal to OC. Therefore, APCQ is a parallelogram. Points to remember. The sum of all angles in a quadrilateral is 360 degree. Parallelograms have opposite sides parallel and equal. In a rectangle, all angles are right angles. A square is a special type of rectangle and rhombus. The midpoint theorem states that the line joining midpoints of two sides of a triangle is parallel to the third side and equal to half of it. Thanks for watching.